Good morning, everyone. Today, I want to move on to talk about a math problem that's going to be useful for the project we're going to be working on. So we're going to be doing a project about garden design, and we want to maximize the area of a garden. So we're just going to start with this idea that we've got our house here, and we're going to put the garden right next to the house. This part here is actually going to represent the area of fencing, or the area of the garden and the fencing around the garden to keep the rabbits out. And the problem is, suppose you have 28 feet of fencing. What is the largest area of a garden you can grow next to the house? So you can rearrange that fence however you want. We'll just keep it a rectangle for this problem. And how would you organize the fence so that you get the biggest area possible so you can grow the most vegetables and have the most food? I'm going to go ahead and call this fencing, I'm just going to kind of put it there but put some variables. So we'll say that this is the width, and that's the same width because I'm making a rectangle. And then this will be the length of the fence. Well, if there's 28 feet of fencing altogether, this orange part all adds up to 28. And once we know that, we can actually start writing some stuff down. So I'm going to put that information in first. So I'm going to say 2 times W plus L equals 28. So we know that information from this problem. And then what I'm going to do is, instead of L right here, I want to make everything in terms of W, and it's because I want to get a function that's in terms of W only, and it's going to be a function for area, and then I want to find the maximum of that function. So the first thing I'm going to do is rearrange this equation so that I know what L is. I'm going to solve for L. I can do that just by subtracting 2W from both sides of the equation. So minus 2W minus 2W. Now these cancel out. 28 minus 2W, those are not like terms, so I'm going to leave them how they are. I'm going to write that L, the length of the garden, is equal to 28 minus 2 times the width of the garden. And then I can replace that in my picture too. 28 minus 2W. Okay, great. We know that the area of the garden is equal to length times width. So if I want to start writing out what is the area of this garden, I can write this formula up here. Area in terms of W. I want only W's in my formula. I could have also done it in terms of L, and the problem still would have worked out, but it just seemed easier for me to solve for L here because all I had to do was one step. So area in terms of the width, well, this function is going to tell me when you just tell me what the width of the garden is, then you'll know also the area, which is kind of nice. So I'm going to do length times width. Area is always length times width, but that's going to be, well, or we could do width times length. So width times 28 minus 2W. When I do that, I can simplify it even more, use the distributive property, distribute W into each of those. My function becomes 28W minus 2W squared. Well, once I have that, I can rearrange it to look like something we're used to seeing more. If we're talking about parabolas, the area in terms of W is also equal to negative 2W squared plus 28W. And then there's no, so this is the a is -2, the a term, the b term, and there's no c term. But this is a parabola because I've got w squared and w. And in this parabola, the a term is -2, the b term equals 28. And we had an important formula that helped us find the vertex of a parabola. Well, the vertex of a parabola is always the maximum or the minimum value of the parabola. And if you look at this parabola, the leading coefficient is -2. Well, that tells us that if you graph the parabola, it's going to be a sad face. It's going to be facing down. And that vertex is going to be at the very top of the parabola. It's going to be the maximum point, which means if we can find that point, we can find the biggest area possible, and it will also tell us what value of what value of w gives us that. So what we'll do is we'll use our formula that we came up with. In this case, w equals -b/2 times a. What that is -28 divided by 2 times -2. -28 divided by 2 times -2 is -28 divided by -4, which turns out to be +7. So here's what we know so far with all of this information. We're almost done, but we know that the maximum area possible if we arrange the fencing this way is going to come when the width of our garden is 7 feet long. What would be the area of the garden then if the width is 7 feet? There's different ways to calculate that. One way is to just put it into this function. So now the area of our garden, when the width is 7 feet, is going to be -2 times 7 squared plus 28 times 7, which is equal to 7 squared is 49. 49 times -2 is -98. 28 times 7, 20 times 7 is 140. 8 times 7 is 56. 140 plus 56 is 196. If I do -98 plus 196, I get +98 square feet. So the area of my garden will be 98 square feet. You would get that same number if you just replaced w with 7. 28 minus 2 times 7, that's 28 minus 14, so that's 14. W is 7, and 14 times 7 is going to be 70 plus 14. No, 70 plus 28, 98. So it comes out the same. So any way you calculate it, we now know, just given this original amount and the shape of the garden and those parameters, we can do all of this math to calculate what's the best way to set up the garden so we get the most amount of food possible. And that is our problem that we're going to start with so that you can do more thinking on the project.